Hello everyone. My name is Minko Gechev. I'm a senior engineer in the Angular team at Google. Today, I'm really excited to share with you what is coming to Angular version 9. Before we get started with technical details, I want to spend some time talking about the Angular community because this is for sure the best community that I have been part with. So currently we have over 24 annual Angular conferences. This is 2 conferences a month, and 30% of them emerged this year. Today we have the privilege to be together on ngsrilanka, which is one of these events. On top of that, we have over 780 Angular meetups worldwide, with over 650,000 members inside of them. Often when I'm attending a conference like the one today or a meetup, I'm getting the question how to contribute. How to contribute in general, not specifically to Angular, but how to contribute to open source in some way. The motivation for this could be different. It could be just giving back to the project you like, or increasing your visibility, or whatever you feel like. So there are different ways to do that. For example, I have been organizing the Angular San Francisco meetup for a while. This is one way to do that. You can help with the documentation of a project. You can write a blog post or help on Stack Overflow, or however you feel like. Pretty much there are infinite number of ways on how you can contribute to open source in general. I want to share with you my first contribution to Angular much before I joined the Angular team. This is from 24th of October 2013 when I opened my first pull request to the project. I was really nervous to open this pull request, to be honest. I spent a couple of hours looking at every detail, like looking at the commit message that I sent and the code modification that I did. I removed the fork repository a couple of times because I wasn't sure whether the contribution is actually worth it or whether it means something. And finally I opened this code change. Look at it, it's just a single line of code. And of course, the first step is always hard. It was a big struggle for me to open this single line of code pull request. But since then I kept contributing and I built a lot of tools for static code analysis that got adopted by Google, and eventually I joined the team about a year ago. I'm saying all of this because one of the main features that was introduced in Angular version 8 was developed by a community member, by Manfred Ster, who worked on differential loading. If you're using Angular CLI version 8, you're already taking advantage of this feature yourself. So since we released version 8, we introduced a couple of improvements in the framework and mostly in the tooling around it. We redesigned the ng app. We introduced an ng deploy command, and we also improved the speed of the production builds of Angular applications. Let us first take a look at the improvement that we did to ng-new. So this is the current ng-new, like the previous actually ng-new application that you're probably familiar with. If you have typed ng-new in the console, you have probably seen this, which is an alright application. It has like links and colors. I guess you have the Angular logo and a couple of useful links, but it wasn't ideal. It wasn't too visually appealing. So we worked with Stephanie Flynn, and here is what we came up with. This is our new ng-new application. So when you type ng-new in your console, you're going to see how to get started with the framework, linked to our angular.io/start. You're going to see a bunch of links on how to create a new component, how to add material or add a new dependency. So this is one of the improvements that we did in Angular 8.3, excuse me. Another improvement that we did was to introduce the command ng-deploy. Here is how it works. What you can do is just use ng-new, create your project. This is going to install all your dependencies. And after that, we can enter the project's directory and ng-add angular/fire. When you ng-add angular/fire, Firebase is going to ask you to select your favorite, your proper, like the right Firebase project. And after that, you can just type ng-deploy. This is going to produce the most optimal production build of your application, and after I deploy the assets to Firebase, we are going to get a link which you can directly use to preview your deployed application to production. So currently we support the following cloud platforms. These are all third-party extensions that we do not maintain, but you can use these extensions to deploy your applications to Google Cloud and Firebase, Azure, by using Azure/ngdeploy. You can deploy to Zeit or to GitHub Pages and Netlify. So if you don't see your favorite platform in the list, for example, AWS, Amazon Web Services, you can use the ngdeploy starter project by Johannes Hoppe from Angular Schule, where you can very easily bootstrap your custom plugin. Another improvement we did was to introduce a speed up in the production builds with differential loading enabled. What we did previously before this improvement was to perform 2 builds of your app in serial. One for the ES 2015 bundles that are used by newer browser, and ES 2000 and ES5 bundles, which are used by legacy browsers without ES 2015 browser support. So these 2 builds in serial were doing a lot of redundant steps, which were not required. And the build was a little bit slower than it was supposed to be. So what we did in Angular 8.3 was to produce only a single build. We are now producing only the ES 2015 bundles. And right after that, we're down leveling them to ES5. So this is a neat improvement. But now let us talk about the future, because that's the topic of today's presentation. I bet most of you are familiar with Ivy already. Ivy is a new rendering and compilation pipeline that we want to introduce to Angular to replace the current one called View Engine. With Ivy, we want to simplify the debugging. We want to lower the memory usage, improve the speed of your tests, of your application in general, make Angular smaller, with faster compilation, improve type checking, and on top of that, keep everything backwards compatible. I'm really happy to share with you today that we're planning to release Ivy in Angular version 9. This is really exciting news for us because, well, we have been working on this project for a while now, and, well, we can't wait to provide it to you so we can see how much Ivy is going to improve your applications. Some early tests that we did show that Angular is going to speed up your tests. For example, for Angular Material, the improvement in terms of tests run is 80%. And it's also going to reduce the memory usage requirements of your unit tests. We reduce the memory usage of Material unit tests with 91%, and for the framework with 30%. So your tests are going to consume less memory and they're going to be faster. But what are going to be the implications on top of the performance of your applications? So usually when we're discussing the performance of a framework, I'm thinking about it in terms of the following triangle. We're looking at whether the framework is tree shakeable, or whether you can get rid of the pieces of the framework that you're not actually using in your application. We're looking at whether the framework generates fewer lines of code or a lot of code. And also we're looking at the runtime. So the runtime is this piece of the framework, for example, of Angular, that your application cannot run without. For example, the dependency injection or the change detection. In terms of tree shakeability, Ivy was built to be tree shakeable in mind. Like, that was the original idea of Ivy. So in terms of tree shakeability, Ivy is the perfect framework right now. We're generating your template in a way that you're using individual instructions in order to render it. And all the instructions that you're not using out of the framework are going to be automatically removed at the bundling and dead code elimination phases. So in terms of tree shakeability, Ivy is going to be much better compared to View Engine. Runtime. So we currently have the size of the Ivy's runtime as big as the View Engine runtime. doesn't sound impressive, but Ivy's runtime is much more complicated compared to Vue Engine, because there we were relying to more complicated compilation process, which was producing a lot of code. But the runtime is pretty much the same as Vue Engine currently. In terms of generated code produced by the Angular compiler, we noticed significant improvements. Some very early adopters of Angular Ivy noticed that their applications became with over 40% smaller. Here are some very early tests that we did as well. So with blue, you can find the ng factories. These are the files that are generated by the current version of the Angular compiler. With red is the Ivy generated code, and with yellow is the baseline, which is the size of your template. All these assets are gzipped here, specifically on this diagram. You can notice that the red column is always smaller than the blue one. So Ivy is always smaller compared to Vue Engine. And it can vary between like 3 times smaller to less than 2 times smaller. On average, we notice that the code compiled by Ivy is about 25% smaller compared to Vue Engine. In fact, you can take advantage of Ivy today by using Angular version 9. You can install the next Angular CLI version like with the next stack. And after that, when you create your application, it is going to use Ivy by default. Currently, we are on Angular CLI version 9.0 next 3 or 4, actually. You can start using Ivy from Angular CLI next 0 already. So please give it a try and let us know what you think. If you hit any issues, feel free to open issues in Angular/Angular or Angular/CLI. Now, let me give you a few technical details about what is the main difference between the Vue Engine and Ivy, only about the things that you'll be actually impacted by, only the things that are interesting to you. So currently, when we take your Angular components, we're going to produce a bunch of files. We're going to produce an ng factory, which is generated code by us that knows how to provide efficient rendering and change detection in your component. We're going to generate an ng summary file, which contains some metadata that we're using internally. We're also going to generate a metadata.json file, component.js, and component.dts. As part of your NPM packages, we're currently recommending you to distribute the metadata.json file, the component.js, and the component.dts file. So this is what ngpackager does, and if you have a custom pipeline for building your libraries, this is what is our current recommendation. The difference is that with Ivy, we're going to produce only 2 files out of your components. We're going to produce the app.component.js and app.component.dts. As you can notice, there is difference between the code that we currently encourage you to ship to NPM with Vue Engine and the code that you need to ship with Ivy. So our current recommendation for version 9 will be to just keep shipping Vue Engine code and do not ship any Ivy code. We have a compatibility compiler which knows how to take your Vue Engine code and compile it to Ivy-compatible format. This is the so-called ngCC. The cool thing is that you don't have to worry about any of this because the Angular CLI is going to do that automatically for you. You need to worry about the compatibility compiler and what code you need to ship to NPM only in the rare cases when you're maintaining a custom built library pipeline. All right, that was everything about Ivy. Now let me share a couple of details about Bazel. So in Google, we have been using Bazel for the past over 12 years now. Bazel is a build tool. I don't know if you have used C in the past or you're using it right now, but C has some pretty good build tools. For example, we have make. Bazel replaced make inside of Google 12 years ago, and it has some pretty good quantities. For example, it has truly incremental builds. It is going to figure out the dependency graph of your entire application, and it knows how to compile the individual targets in parallel if they don't depend on each other. This way, it is going to utilize all the CPU cores that you have on your machine, and if you don't have enough cores to parallelize all the build actions, It is even going to start building your application in the cloud if you configure it to do so. It is cool that Bazel is going to detect build dependencies between your front-end and your backend. So if you change something in your backend, for example, your RESTful API, Bazel is going to detect that it needs to rerun your end-to-end tests in the front end to make sure that your application is still running. We have a lot of adopters of Bazel currently. For example, we have Google, Lucidchart, DigiOcean, Universe Microsystems, and many others. A lot of the adopters are using Bazel without Angular. So just to clarify, Bazel is not anything Angular specific. You can use it with C, with Java, with C#. You can use it with pretty much any technology, any language that you can come up with. Specifically for Angular, though, for the Angular monorepo, we noticed some significant improvements with Bazel. We dropped our build time from over 60 minutes to about 12 minutes by introducing remote build execution with Bazel. So in order to simplify the way you can try Bazel, we introduced Bazel schematics for Angular CLI. This is a very highly experimental collection of schematics that can produce Bazel-compatible Angular CLI application. So you can give it a try, but yeah, don't expect too many wonders out of it. Basically, this is going to bootstrap an Angular application that you'll be able to build with Bazel, but in the more advanced use case, for example, the customers that you saw on the previous slide, they're not using Bazel with the Angular CLI. They're using Bazel independently so that they can run the build across not only their front end, but back end and other services as well. And here comes the question, should I learn Bazel? Well, if you want to use Angular, only Angular, and you are not maintaining a huge project, a couple of hundreds of thousands of lines of code, you don't really need to know Bazel. Actually, you don't need to know Bazel at all if you want to use Angular. But in my personal opinion, it is worth to understand Bazel if you want to grow as a software engineer, because it teaches you very good practical skills and it builds your knowledge. It helps you to learn a technology that you can transfer across multiple different areas. For example, if you are currently building web apps with Angular, but you want to move to the backend, if you know Bazel, you will be able to do that migration much seamlessly. You don't have to learn the custom build toolchain of your Java backend. Like, for example, you don't need to learn Gradle or Maven. You can use Bazel for both Angular and Java. So this is going to be much simpler for you. Again, you don't need to learn Bazel, of course, if you want to use Angular, but I think it's going to be a valuable skill in the long term. All right, so what we looked at today. We looked at the amazing Angular community, and I'm really happy to be part of it. I'm currently organizing the Angular SF meetup, and you can't imagine how many interesting people I have the opportunity to meet this way. We took a look at the new features in Angular CLI version 8.3, the redesigned ng-new app, and ng-deploy. We looked at our current plans to release Ivy as part of version 9, and well, we looked at Bazel as well, so I would recommend you to have a look at it. Well, that was everything from me. Thank you very much for your attention.